So now, before starting with the question or before looking into how does an epidemic spread, let us look at two important things. So I would like you to ask this question from yourself. Which two factors do you think are the most important? Which two factors are required when we want to model a disease spreading on a network? So assume there is this classroom and there are some people, some students in this classroom, and one of the student catches a flu there and this flu is spreading through the network. So which two things will you require if you want to model the spreading of this flu? And here goes the answer. So the first one is the pathogen itself, about the flu itself. So what is spreading on this network is important. For example, its degree of contagiousness matter, how contagious this flu is. Taking an analogy with the spreading of an idea, as we have seen, something like a piece of code spreads less quickly as compared to a juicy piece of gossip. Similarly, in the case of diseases, there are certain diseases which spread more quickly as compared to other diseases. If you talk about diseases like measles and flu, they spread quite quickly as compared to the diseases like Ebola and HIV. So first of all, what is important is the pathogen. We need to know how contagious this pathogen is. And the second, which is the obvious for a network scientist, of course, is the network. Yes, we need the network on which this pathogen is spreading. Does the network really matter? Yes, it matters. So if you look at the network which is shown to you in this figure, you can see that there are quite a less number of edges in this network. The network is less dense. Rather, we call that this network is sparse. So you put any disease over there, it will slowly move through this network. Rather, it can die away quickly. But if your network is, say, something like this, and I put a lot of edges there between these people, so you put any disease on this network, and this disease will quickly spread on this network because your network is dense. So yes, one thing is the density of the network, or let's say the sparsity of the network. It affects how your contagion is going to spread on the network. Rather, there is one thing very interesting to note here is, do you see that this pathogen has something to do with the network? So let's say I want to model the spreading of flu, and I can be having a network like this, and the network is going to be quite dense, and actually the network is dense for the spreading of something like a flu, because even if you come in because flu spreads even if you come in close proximity with someone. So even if you just stand and talk to a person for 5 minutes, you can catch flu, right? And even people do not need to come in close contact together. Let's say that you have worked on a piece of code on your keyboard, and then you go away, and then your sister comes and she also works on the same keyboard. Even this thing can make a flu to spread. So this common cold virus, it can spread even through keyboard. So the network is going to be very dense in the case of such a contagion, if the contagion is a flu. But let's say I do not want to model the spreading of a flu. I want to model spreading of, let's say, HIV. So in the modeling of HIV, will the same contact network work? And the answer is no. In the case of HIV, since it spreads with the help of sexual contacts, there will be quite less number of edges which will be counted in this contact network. So the network in the case of HIV is going to be very sparse. So whether your network is dense or your network is sparse also depends upon what kind of a pathogen we are talking about. If this is a pathogen like flu, then the network is going to be quite dense. And if the pathogen is something like, let's say, HIV, then this network is going to be very sparse. So here, while your blue edges depict your contact network for the spreading of flu, orange edges or the orange nodes here, this is the contact network for the spreading of HIV, which is quite sparse. So these are the two things which are most required for modeling the spreading of a disease. The first one is the pathogen, how contagious it is, and second one is obviously the network structure. So we'll be using just both of these two things to model the spread of diseases on our social networks.